Good morning, students. On today's lecture, I'll solve Additional Mathematics Paper 2, 4037, variation 22, May-June 2017. The first question is modulus or absolute value math of equation, solving an equation 5x plus 3 in the modulus equal to 1 minus 3x in the modulus sign. So when it's like that, both of them are positive, and another time one of them are negative. Okay, if you put both of them are negative, 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 cross out, it's gonna be positive both sides. So what are you gonna do? 5x plus 3 equal to 1 minus 3x. That's one of the option. Okay, another option we can say 5x plus 3 equal to minus 1 minus 3x. This is going to be positive, this is going to be negative. Don't take both of them negative. If you take both of them negative, then negative, negative cross out, and it's going to be something like this. Okay, so it's the same thing. But you can do one thing. You can take this one positive and this is negative. Okay, that time it's again same thing. Okay, you can just transfer the sign over here, and it's going to be the same thing. Okay, so let's see. If I solve it like this, 3x comes this side, so 5x plus 3x equal to 1 minus 3. So over here is 8x equal to minus 2. Therefore, x equal to minus 2 by 8 equal to minus 1 by 4. That's one of the solution. And from here, 5x minus 3, if I take the bracket of minus 1 minus minus plus 3x, now bringing this 3x to that side, that's going to be 5x minus, let me write down that, 5x minus 3x, and it's going to be minus 1 plus 3. Transfer the position over here. This 3 comes here, and this 3x comes over here. Okay, so that's going to be 2x equal to 2 minus 3. Oh, sorry, this one was positive. This one was positive, so that's going to be negative. So this is going to be negative 4. So therefore, x equal to negative 4 divided by 2 equal to negative 2. So my answer, final answer should be x equal to negative 2 and minus 1 by 4. Okay, so that's done. Now, without using a calculator, express this algebraic expression, actually arithmetic expression, in the form of this. When there is no variable, then we can say it arithmetic expression. This one in the form of a plus b square root 5, where a and b are integers. Integers means they are decimal places. Okay, no fraction, it's just an integers value. Okay, now without using a calculator, most of the time when first students did that, they said, what if we use the calculator? Well, look at this, it's 5 marks. If you use the calculator, it's going to give you the direct answer. So direct answer will not award you with any marks, so you have to show every steps to get all 5 marks. Okay, I'll show you how to do this. Okay, 1 plus square root 5, then 3 minus square root 5 to the power minus 2. You probably know one of the rule of indices. If you have a by b to the power minus m, then b gonna be from the denominator, it becomes numerator, and a becomes the denominator, and the power becomes positive. Okay, this is one of the rule of indices. So that's what I'm gonna do over here. So I'm gonna make this one positive 2. So denominator gonna be in the numerator. I'm not gonna explain that how this thing happens. Okay, just you have to know this formula right now. Okay, and we're gonna do the rationalization. That means taking the bracket off from taking the square root off from the denominator. So to do that, I'm gonna multiply denominator with the conjugate pair of this one. That means the term gonna be same, but the in between sign should be different. If it's positive, it's gonna be negative. So 1 plus square root 5, I'm going to multiply this with, okay, let me write down the top numerator. I'm gonna multiply the denominator by conjugate pair of that, 1 minus square root 5. I cannot do that unless I do the same thing with the numerator. Okay, so the power, don't forget the power is 2. Now this looks like a plus b, a minus b. A plus b, a minus b, that gives me another algebraic formula, a square minus b square. Okay, so a square minus b square. So in the denominator, I can write down 1 square minus square root 5 square. And over here simply I can take the bracket up and multiply. 3 times 1 is 3. 3 times minus 1 square root 5, that means minus 3 square root 5, minus square root 5 plus 1, that's going to be minus square root 5, minus minus plus square root 5 whole square. And don't forget the square sign. Okay, most of the students, they forget about that. So this square root, this square, this square root, this square cross out. And over here is going to be 3. 3 square root 5 minus 1 square root 5, that's going to be minus 4 square root 5 plus 5 divided by 1 minus 5. Then I have 2. 3 plus 5 is 8. And here minus 4 square root 5. And below here minus 4. That square. I'm going to draw a line and coming from here to here. So if I take negative 4 common on the numerator, then it's going to be square root 5 minus 2. And below here in the denominator, I have minus 4. And on the top square, so this cross out. So I end up with this minus square root 5 minus 2 whole square. And this is in the formula a minus b whole square. That gives you a square minus 2ab plus b square. So square root 5 whole square minus 2 square root 5 times 2 plus 2 square. So again, similarly, whatever I have done over here, square root cancel out. So that's going to be 5 minus 2 times 2 is 4 square root 5 plus 4. So 5 and 4, that becomes 9 minus 4 square root 5. Look at this. It's in the form of that. So if they didn't ask you to find out the value of a and b, it's already done. So that should be your answer right over here. But I want to show you something. A, look at this A. A is going to be 9 and B, see that in front of B there is a positive sign, but over here I have negative sign, so it's going to be minus 4. Don't write down positive 4, then it's going to be wrong. Okay, but you don't need to do this. Just up to here is fine. Okay. All right, I'm going to do question number 3. Again, without using a calculator, factorize the expression 10x to the power 3 minus 21x squared plus 4. Now, in one of the last, I think, I don't remember the year, but this type of maths, solving cubic equation or degree to be more than 2, I use, I think, vanishing method. Today, I'm going to do synthetic deviation method. Okay, but before that, I have to do trial and improvement method. Let function of x equal to 10x cubed minus 21x squared plus 4. Now I have to choose the value of x to make this one 0. So I'm going to have a factor then. Okay, when this becomes 0 for any values of x, that value becomes the root of this function. Then x minus or plus that value should be the factor of this function. Okay, so let's see. If I put the value of x equal to 1, so 10 minus 21, that's minus 11 plus 4, that's not 0, okay? What if I put 2? So 2 to the power 3 is 8, that's 80, plus 4, 84, and over here 2 square is 4, and then minus 21, that's going to be minus 84. So therefore, when x equal to 2, function of 2 gives me 0. Therefore, x minus 2 is a factor of function of x. Okay, you can use the calculator to save time. You put the cubic equation to solve it. Okay, then you're gonna find a solution when x equal to 2. Then you can do this one. Okay, that's easier way. Now when you have that, now I'm gonna do synthetic division method. That one is, I'm going to write down only the coefficient of x, okay, coefficient of variables, okay. X to the power 3's coefficient is 10, then x squared is minus 21. If you look closely, the power of x, this is 3, this is 2. Now x to the power 1 is missing, and this is constant term, or x to the power 0. Whatever is missing, we're going to write down that 0, and over here plus 4, okay. Now, I'm going to draw a line over here and a line over here. and this last line is going to be the remainder, or if it's 0 then that's going to be a factor. And I have a factor x minus 2, so I'm going to write down here 2. This 10 comes down as it is, 10. Now I'm going to multiply 2 times 10. 2 times 10 is 20. That's going to go, see, multiply this 2, and that answer should be, I'm going to multiply this 2, and the answer should be right over here. That's going to be 20. And don't change sign, just add it. 20 minus 21, that's going to give me minus 1. Again, I'm going to multiply 2 with minus 1. 2 times minus 1 is minus 2. Add that, minus 2. Again, 2 times minus 2 is going to be minus 4. See that? That becomes 0. That's just because this is a factor. If it was not a factor, it was just kind of a divisor, then I would have had some non-zero value over here. Okay, that showed that if this one was non-zero value, then it wouldn't have been the factor of this function. It would have been the divisor of that function. Okay, but this is 0, so this is a factor, pretty good. And the degree was cubed. Now this one degree reduced to squared. From cubed it's a square, so I'm going to rewrite that 10x squared, that's minus 1x minus 2. Okay, now this is something like a middle term break, so I'm going to use the middle term break to do that. 10 to the 20, another pair of factor is 5 times 4, so it's minus a minus 5x plus 4x minus 2. If I take 5x common from here, 5x, that's going to give me 2x minus 1 plus 2 common, x minus 1. Therefore, I have here 2x minus 1 and 5x plus 2. Now I can write down this whole function. Don't forget this factor. Okay, there is a cube, so there are supposed to be 3 factors usually. Okay, it cannot have more than 3. It might have 2 if you have equal roots. So that's gonna be x minus 2, then 2x minus 1, and then 5x plus 2. Okay, so that's done. Now next one, question number 4. The point P lies on the curve this. The normal to the curve at P, same point, has the equation normal. This is the normal. Okay, so normal equation is this. Find the coordinates of P and the value of K. Okay, so what I'm gonna do, see, there is some, what that means, that this is some kind of curve over here, and the tangent should be right here like that. This is the tangent, and then normal, it doesn't have to be political correct. I'll just show you this. Okay, this is 90 degree and that's normal. So what they're saying, this curve's equation is given, that's y. Okay, and this one normal's equation is right over here. Okay, so that's the normal's equation. Okay, so what happened, and this particular point is P. Now this tangent, normal, and the curve intersect at P. Okay, so what I'm gonna do, the gradient of this one at this point is also the gradient of this curve. Okay, so I'm gonna rewrite that in the form of y equal to mx plus c. Then m is gonna be gradient of the normal. Okay, over here. So 5y plus x equal to k. Then I can write down 5y equal to minus x plus k, transpose x to that side. So y is going to be minus 1 by 5x plus k by 5. Okay, when I do that, then gradient of the normal is minus 1 by 5. And what about the gradient of this, okay, curve? So y equal to 3x squared minus 7x plus 11. Okay, and its gradient dy dx, that actually gradient of the tangent. Okay, so I'm gonna write down that, and this is gonna be 3 to the 6x minus 7. Okay, so that's that, and this is negative. Yeah, gradient of the normal is this. Now we know that if the gradient of the tangent is this, the formula goes gradient of the tangent times gradient of the normal equal to -1. Therefore, gradient of the normal supposed to be -1 by gradient of the tangent, and in this case is 6x minus 7. Now what can we do? According to the question, this and this are equal, because this is also gradient of the normal, this is also gradient of the normal. So -1 by 6x minus 7 equal to -1 by 5, minus cross out. Now cross multiply, so it's going to be 6x minus 7 equal to 5. 7 goes there, so it's going to be positive 12. So 6x equal to 7 plus 5. Then x equal to 12 divided by 6 equal to 2. I got the coordinates of x coordinates of that p. So write down p x coordinates. I got 2. Okay, now I have to find out y coordinates. Okay, so go to this this point, go to this curve. Y equal to 3x is 2 square minus 7 times 2 plus 11. Okay, so what that gives me, 2 square is 4, 4 3 is 12, minus 14 plus 11. 12 minus 14 is minus 2, that's gonna be 9. So the y coordinates would be 9. So I already found the coordinates of p, and now value of k. Look at this equation, 5y plus x equal to k. This line go through p, therefore through this point. Okay, so value of y is 9 and x is 2 equal to k. Therefore k equal to 9 5s are 45 equal to 47. So that's my answer. K's value is 47 and p's value is 2 and 9, the coordinates. Okay, the next one is I'll do this one. Okay, now show that d dx of this. Okay, so I can see this is a product rule, so I can go with the left hand side, and then when I differentiate that, 0.4 x to the power 5 d dx of 0.2 minus ln 5x plus 0.2 minus ln 5x d dx of 0.4 x to the power 5. Now what to do? Now I have 0.4 x to the power 5. This becomes 0 and this becomes minus 1 by 5x, then differentiate that again, so I'm gonna have 5 plus here 0.2 minus ln 5x, then if I differentiate that, it's gonna be 0.4 times 5 x to the power 5 minus 1 is 4. Okay, so this 5 and this 5 cross out, and this cross out, x to the power 4. So I have negative 0.4 x to the power 4, and over here negative 0.4 times 5, that's gonna be 2. Okay, so that's that 2, and there's 0.2 times 0.2, that's gonna be 0.4. So that's gonna be plus 0.4 x to the power 4. Remember it was 2. Now over here minus 2 2 x to the power 4 ln 5x. Now this and this cross out. Okay, this two cross out. Okay, so I have this negative 2x to the power, let me write down that, negative 2x to the power 4 ln 5x. It does look like this, and then x to the power 4 x to the power 4 ln 5x. Therefore k equal to minus 2. See that, minus 2. So this one is done. express ln 125x cubed in terms of ln 5x. Okay, ln 125 can be written as 5 cubed and x cubed, so that's cubed, and 3 gonna come front, and that's gonna be this. Okay, this is expressed as ln 5x. That's done. Hence find integration of that. Okay, so what we're gonna do, see that we're gonna compare these two. Okay, whenever we have this, okay, we can write it exactly like that. Okay, let me show you step by step. Okay, so x to the power 4 in the place of this, see that I can write this, so 3 ln 5x dx. Okay, now what happened, x to the power 4, see that x to the power 4 ln that, so I'm gonna bring this 3 outside, so I have x to the power 4 ln 5x dx. Now watch this, I'm missing -2, because if I have -2, that's equal to right hand side. Okay, it's not right hand side, but almost right hand side, because it's k and there is -2. Okay, now compare this. If I differentiate this and get that, if I integrate that, I should get this. So this something equal over here except -2. So what I'm gonna do, I'm gonna put -2 over here, but I cannot do that unless I divide this one. So this cross out, I'm not changing anything. So that's gonna be -3/2, and this is gonna be, when we integrate, we're gonna get this part, right? So it's gonna be 0.4 x to the power 5, 0.2 minus ln 5x, then some constant c. Okay, so they didn't say simplify or anything. I'm gonna keep that answer like that. Okay, I'm not gonna spend too much time on that. Most of the students, they just keep simplifying that and then they tend to make mistakes. Don't do that. It didn't say simplify and show it in this form. Okay, such as this one, it says that the question, it says that show it in this form, so we had to do a lot of things. Okay, but here it didn't say anything, so keep it as it is. Okay, now show that the roots of this are real for all real values of p and q. Now what I'm gonna do, I'm not sure about that, what they're asking, but when it says real roots, it's something to do with discriminant, right? So discriminant is going to be b square minus 4ac. What is b square? B square is p minus q. So p minus q square minus 4a is going to be p, and q is going to be minus q over here. Okay, c is going to be minus q over here. If I take the bracket of it, it's going to be p square minus 2pq plus q square, the formula of a minus b whole square, and here minus minus plus 4pq. Now if I simplify that, p square, this and this, that becomes plus 2pq, and this becomes q square. So p plus q whole square. Okay, that's again a plus b whole square's formula. So no matter what is the value of p and q, it's always gonna be, since there is a square, it's always gonna be positive. So this value itself is non-negative value. Since the p plus q square is a I like to say non-negative value, because see, I can say positive value, but the reason I said non-negative value is sketchy. You know that it might be negative inside, but there is somehow because of this square is given on the top, therefore it's never gonna be negative. Okay, so it's non-negative, therefore b square minus 4ac is always greater than 0, or if they are equal and different sign, then equal to that. There, when it's like that, discriminant is like that, we can say that all the roots are real. Okay, and that's, they say it show, so it showed. Okay, that's done. Let's do the next sum in question number 7 and onwards in next video. Okay, I hope you understand that. If you have any question, leave that in the comment box. I'll get back to you. Okay, thank you. Have a good day.